Hello, this is the National AGS, National's first superhet receiver for the AWA Communication Technologies Museum. We're going to talk about the rise of superhet receivers, and we'll also some historically significant superhets. Now, I want to give you an introduction to the AGS and AGSX, which National called the National AGS Communication Type Shortwave Superheterodyne. We're also going to talk about some very similar and rarer follow-up Airways receivers that evolved from the AGS. Here's a nice picture of a National AGS receiver in the tabletop rack with a nice coil rack and open face speaker in the AWA Museum. So there's many people involved in the rise of superheterodynes. First of all, it was Reginald Fessenden. He came up with the heterodyne principle. And then Edwin Armstrong and Harry Houck produced the first practical superheterodyne sets. Paul Godley used a superhet in the 1921 transatlantic test that showed that shortwaves were usable across the oceans. Of course, David Sarnoff built an empire at RCA around the work of Edwin Armstrong and Harry Houck. James Millen brought professional radio craftsmanship to National and other companies. And James Lamb, who was a industry consultant, worked with many companies, came up with single signal and other modern communications receiver enhancements. And we'll talk about all that. So, of course, Edwin Armstrong's also the father of the regenerative and super regenerative receiver. This was a very simple way using positive feedback to have a very high sensitivity and also some selectivity possible with minimal hardware. The downside is if you set the oscillation too high, it'll radiate to other people. But if there was a skilled operator using the set, they could do a pretty good job. Now, TRF receivers, they had sufficient sensitivity and selectivity for 1920s and 30s radios. At first, each stage was tuned separately, but their performance was eventually surpassed by the superheterodyne. The secret of the superheterodyne is that it converts the incoming radio signal to a fixed intermediate frequency for better amplification. And it provides excellent sensitivity over a wide range of frequencies and also excellent selectivities, and including bandpass filtering added to the IF. Now, the superheterodyne tends to be more complex, use more tubes and more components. Now, who invented the superheterodyne? Well, we Americans think that, again, Edwin Howard Armstrong, who worked in Paris during World War I on radio projects, invented the superheterodyne. The French also were there doing the same thing. So here's Irwin Armstrong and his Army buddy, Harry Houck, and three of his original superheterodyne prototypes. So they were the first to build a working system, but they were late to the patent office. Here's one of the prototypes superhet receivers, and nice unit. Here's a very similar set in the Smithsonian, supposedly the second set. And if you compare the two pictures, this picture has two more tubes on the right unit, which means instead of 3 IF stages, there were 5. Now, here is a superheterodyne receiver prototype that was built by Armstrong and Houck for RCA in 1923. It was one of six. And as I understand it, three had the meters in the middle and the other three did not. And this one is currently on display at the National Museum of Industrial History in Bethlehem, Pennsylvania. It's part of an IEEE display, I believe. So here is Armstrong's first portable superhet, which was eventually given by his wife, Marion Armstrong, to the Henry Ford Museum. There's so who really invented the superhet? So Armstrong's considered as the father of the superhet, but he delayed filing his patent till he had a working prototype. An engineer in Germany, he actually posted a clearer theoretical patent almost identical to Armstrong's 6 months before. And there was no communication between them. So it was a case of simultaneous inventing. A gentleman named Lucien Levy, who was in the French Army working on radios, he was first to the patent office by 2 years. But his first version of the patent was highly theoretical and did not have an IF amp, for example. Another French military radio engineer, Paul Laut, worked with Levy, and Laut said he wrote the original report on heterodyne amplification and shared it with his team, of which Levy was on the team. Then he went on medical leave for 6 months because of tuberculosis. And when he returned, he found out that Levy had patented his work. So this was from a French article translated in the 1991 review. I was reading a book about Australian radio for another upcoming presentation, and this is what it said. The supersonic heterodyne principle, French patent number 493,660, filed 4 August 1917 by Lucien Levy of Paris, and that he had a subsequent patent that clarified his original one. So he was the fellow who ultimately got the patent. So Lucien Levy, here's his first. He was a radio manufacturer and distributor in France. I've seen a number of radios that referenced radio-LL, and now I come to learn it means Lucien Levy. And so here's Levy's superheterodyne A, which he brought out in 1924. Here's the insides of that same set. 8 tubes. One of the characteristics of early superhets is a rather long IF amplifier strip constructed with RC coupling between the stages. And this is for the high amplification of the IF. So here's Paragon Paul Godley in preparation for the 1921 transatlantic test. You can see he has an IF strip that he's working with. And here's another picture attributed to Paul, also still working on what appears to be a superhet. So Godley's superhet receiver was one of the primary reasons why the 1921 transatlantic test was a success. The other was that he had met Beveridge on the way over and learned about a Beveridge antenna, and he used that as well. Here's the internals of Paul Godley's superhet in the schematic. There was also a external heterodyne stage, 1 tube for CW reception, so a 10-tube superhet. Even Kirk and Spock, when they were stuck in the past on one episode of Star Trek, they needed to try and call for help, so they were building a superhet as well. The only legal superhet that I'm aware of from 1922-24 was a small line of broadcast station monitors built by Western Electric, the Model 4A, B, C, and D. And of course, they used these small 215A vacuum tubes, which were also only used for commercial or military applications in the United States. Here's what a Western Electric 4D receiver looks like complete in a workable condition. A box for the batteries, the receiver itself, a loop, and to act like a real radio, it needed some audio amplification, so you would need a 7A amplifier to go with it as well. The bottom line is that Western Electric at this point, they left the consumer radio market and focused on commercial radio, and much to the happiness of RCA. So I have met a number of superhet collectors uh, in working on this presentation. Here's a picture of part of an amazing collection by Dave Willenborg, and he was very helpful. Um, he told me there was hundreds of suppliers of superhet kits, and they were kits so they get around the Armstrong patent. Um, Ultradyne, Rembler, Victorine, Lutz, um, E.H. Scott, Moore, uh, et cetera, Silver Marshall. And typically these receivers were very long, had a lot of controls on it. And if you look inside, it looks like it was a kit. Um, so here is possibly the first superhet kit, Lutz EIS Model L. And just looking at it, I'm sure it was very complicated to build and also to use. And you have to wonder how many of these sets were bought, and they never got them working. So here's another part of a superheterodyne kit, selling instead of RC coupling, some transformers there. Here's so this a couple of years later. Here's a nice Presley Sangamo superhet, which was also a kit, but this one was built very nicely. And if you look inside, the manufacturer has started to do some of the work, making the kit much easier to put together by creating this chassis, so to speak, for all the tubes. Here's the superhet receiver that Armstrong used, demonstrated to David Sarnoff and RCA Chairman Owen Young prior to the 1924 season. And as a result, Sarnoff and Young decided to cancel millions of dollars in orders and replace them with a couple of super heterodyne receivers. And so the first two sold by RCA were the AR-812 and 813. And just these two superhet models, they sold 164,000 of them in 1924 to 25. So RCA had a very lucrative monopoly through 1930 or so. And superhets tend to need more tubes, which is just fine with RCA because they've got a tube division. And here's the AR-812, what I would call a luggable radio, and 6 tubes. And the equivalent cost of this set was about $5,000. So, and said it was a commercial success with better performance than competing receivers. Now, besides the better performance, it had fewer controls than many of the radios that were being built at that time. And as the 20s progressed, customers increasingly wanted simple to use one dial tuning. And with a super heterodyne, it's easier to do that. So the other manufacturers using TRF type technology, they needed to do something to help address the market. So here's an inside of two Greeby synchrophases. One's an early model, and you'll notice that each stage is tuned separately. There is no chains. And later, the later model synchrophase had the chains to help provide a single dial tuning for customers. Here's a Notwater Kent beautiful set from the Ralph Williams collection that's in the AWA Museum, and it's dated 1928. And Atwater Kent is marketing. He's leading with the comment, a one dial radio. So RCA's monopoly ended in 1930 because of threats of antitrust suit and also pressure from other manufacturers. So now legal superhets could be made by companies other than RCA. Now, this is a great book. Raymond Moore was quite the radio historian. He had a series of these books on communications receiver. And in there, he looks through all the old QSTs and tries to identify what types of sets were being were mentioned in the articles and in the pictures. And he said in 1931, only 11% of the references were to superhets and 78% were to home built. But by 1936, 77% of the receivers were mentioned were superhets and only 20 home built. He also says that the first commercial superhet receiver was the Hammerland Comet, produced late in 1931, and an improved Comet Pro followed very quickly in the spring of 1932. And then afterwards, a more advanced receiver, the National AGS, appeared in July 1932. So National, before superhets, they made a number of regenerative and TRF sets. In the 20s, airmail was gaining traction. And at first, they could only fly the mail during the day, and then they would land and put the mail on trains, and then the train would run the mail forward. And then in the morning, they would take the mail off the train and fly it another leg because the planes could go a little faster than the rail. Of course, the pilots all had to fly visual, and weather was their nemesis, and they needed weather info, of course. Here's some of the early surplus Navy equipment used by some of the earliest airmail radio stations. And here's a picture on the left shows some type of a radio set up in a de Havilland mail plane, and over at the right is a radio telegraph set up at an Airways radio station circa 1925. The next step in the National Airways was to be flying day and night, and the Airways division was a part of the Department of Commerce, and who knew beacons better than the lighthouse service? So for a time, the aeronautics branch, Airways division, was under the lighthouse service for just a few years in the early 1930s. During that time, approximately 1,500 airmail beacons, light beacons, were set up approximately 5 miles apart across the country. And they did other things too. They made concrete arrows, or they would have logs that point to the next station. So again, now the pilots had a visual reference at night that they could fly. So as this happened, they set up more new airway stations with a new generation of radios and even some early landline teletypes. So here's a typical Airways station shown here. And in the bottom left-hand corner is a very early Airways receiver prototype. So here's an aerial view of a radio beacon site circa 1940. You can see the light beacon. You can also see an arrow made of logs painted orange or yellow pointing to the next station, and the name of the station on the roof, and some radio antennas there as well. So, in July 1932, National introduced the most advanced communications receiver of the time, the AGS. That stood for Aeronautical Ground Station. This receiver was developed for aircraft ground station use in conjunction with the Airways Division, United States Department of Commerce. Nine-tube superhet, tuned RF stage, and it had automatic volume control. And it was advertised in QST for affluent amateurs who could afford the very best, but very few of those could afford this type of receiver in 1932 or 33. Here's the first AGS ad in QST, June 1932. It says it's spectacular in ability, and it's everything's of the highest quality, designs, part, and craftsmanship, and it stresses it's not an experiment and it's not a kit. Here's some of the outstanding features, and here I have one of the Airway sets, fairly disassembled. It's terrific shielding on the tubes, and then the cabin itself is heavy gauge metal. It's very well thought out. It says tuned RF stage, electron coupled oscillator, no frequency drift. Single dial straight frequency line tuning, coil change from the front panel, automatic volume control, extremely rigid mechanical construction, frequency range 1500 to 20,000 kilohertz. Band spread coils eventually were available, and you could run it on AC or battery operation. So, and a panel switch for phones or speaker. And in the latest models, the AGS X, you could get a mechanical filter, a crystal filter for signal. Here's you'll see a mix of both of these, a phenolic tube socket and also the ceramic tube socket in AGS receivers, depending on the age of it. James Millen, to help adoption of his receivers, always wrote radio articles and published them in QST and other places, talking about the new radios and all the benefits and how it's made, and he really set the stage, the bar very high. So, how many versions of AGS were there? And again, I went back to Raymond Moore's 4th edition communications receiver because he was the only person that had any information that I could find. He says the first model AGS was released 1932 and has a Type N dial developed for aircraft ground stations in conjunction with the Airways Division, U.S. Department of Commerce. Here's a picture of an Airways station, Medicine Bow, Wyoming, early 1930s. And if you look over to the right, you can see 2 such receivers. And the reason why I know that they're the earliest model is they have the longer data tag underneath the main tuning dial. And that's here. I have a first version AGS, and it has this long data tag. Mine's missing, but this is a picture of a data tag from Henry Rogers' set. And so it goes right here underneath the main tuning dial. The interesting thing about the first version AGS is it was known as the RHM, not the AGS. You'll notice on the data tag it says RHM. And there was only about 100 or so RHMs manufactured. Another clue that you might have an RHM is that if it says national in the type in dial as opposed to the later velvet vernier. So, so here's the type RHM had four front panel controls plus the main dial, a rather long, thin data tag, and national in the dial. Now, an RHM coils are different than the later AGS coils. So there's an RHM coil on the left, AGS coils on the right. The RHM coil box is just a wonderful thing. It's a solid block of wood with holes drilled in, has a heavy aluminum front panel. All the coil holes are felt lined. And so it has depth and it's fairly heavy and provides great protection for the RHM coils. Another interesting thing is that because my RHM did not have a data tag, um, the only clue to its serial number are the coils that came with it. And it turns out RHM coils are serialized, where later AGS coils are not. And my set came with a mix of coils, serial number 50 and also serial number 24. So my guess is that my set is one of those. Here's a slide, the next version AGS. Um, it says velvet vernier in the type in dial, and the data tag is much smaller rectangle. It's not as wide as the dial is. Here's a later AGS coil rack. So they went to a different manufacturing scheme and just had the coils held in by clips, and they're not serialized. So in reading Moore's book, I put together this chart talking about the differences between the various variations of the AGS, starting with the RHM in 1932. And I give the tube lineup and whether or not it has a crystal filter and what type of main dial it has. The variation one, the next version, the red denotes a change. So they changed the HF oscillator tube and the ABC tube. And then the variation two, they changed the audio out tube to an 89. Variation three, CW oscillator changed to a 36. Variation four, they changed four tubes. Variation five is interesting. All they changed was the type. They went from a type N dial, which is a nice metal vernier dial, to a type B dial, which is the same as you find on the SW3. So that's kind of they must have run out of N type Ns is all I can figure. And then the last model, the AGS X, it does have a crystal filter. Um, Now, I'm very interested in serial numbers, and the ones that I've seen so far for AGSs are start with a E and F. And my guess is there's only about 100 per run because the numbers tend to be E, XX, and FXX. And even if you have an AGSX, a lot of times the data tag will not say that. It'll just say AGS. And uh, if you happen to have an AGS or an RHM, I would be very interested in knowing what you have and what the serial numbers are um, for an informal AGS registry. So here's the three national dials that we're talking about today. The metal type N dial, then you have the type B dial, same as on a SW3, and then you have a slightly more advanced plastic dial. It's a type BX, which looks like a type B dial, but it's illuminated. It has a pointer in it. So, and it's a bit more fragile than the type N. So here's a picture of the AGS Variation 5 from Raymond Moore's book. Um, It says the standard round dial replaced with a velvet vernier type B. I have not seen one of these sets in person, but they must be out there. And then variation 6, the AGS X, can have a filter, and it has a number of new controls. It has 8 panel controls total. You have a CW oscillator, your variable BFO control, you have your selectivity control, and then there's a serial, off, and parallel crystal filter switch that's been added as well. So here's just a little bit about a makeshift crystal filter.
I will try each crystal on the testing jig so you can tell which ones are faulty and which ones are okay. Here's our first crystal. It's one of those cheap crystals for 7023. If you tune across the band, you'll hear a big increase in noise around the crystal's fundamental marked frequency. The crystal is operating as a crude narrow bandpass filter.
I have 2 AGS X units here, and they have different crystals. Both are Bliley crystals. One is much larger, cased in black. You can see it in the background. In fact, there it is right there. And you can see this is the place, the location of the crystal filter in an AGS-X. And so here's they were 500 KC IF. And this is the smaller of the two. And the paperwork here says that the little button on the top of the crystal was not to vary the frequency, but it was to help ensure against damage of the crystal during shipment. It's a small tightening screw, and you're supposed to release that before use. And then here's an advertisement in the bottom right corner for a single signal filter. So this was good business for Bliley. The FB7 was designed for hams. It was a cost-reduced AGS, had one less stage. It only came with one set of coils, no power supply or speaker, for about $55. Here's an ad, October 1933. It talks about the AGS X, and it also mentioned band spread coils. So that's a new feature as well. Here's a slightly later ad, a QST June 1934, and they've added a nice wooden box. Tried to make it more attractive to home users. Here's a picture of that shielded walnut veneer cabinet, a tabletop cabinet. These are very rare. Again, this is helping the AGS-X being marketed to wealthy hams and shortwave listeners at a price of approximately $295, or about 6 times what an FB7 would cost a regular ham. Here's a set of the very rare band spread coils for 160 meters, 80 meters, 40 meters, and 20 meters. It's very hard to find. Here's an example of a very high-end AGS-X user, Alice Burke. She worked for the Chicago Tribune. She passed a lot of traffic. She stayed involved, and here's her QSL card. And if you look on the back, she had a national AGS-X, and then later on she added an HRO, which of course evolved from the AGS-X. I was lucky to be able to purchase my friend Richard Wayne, W4LN's AGS-X, serial number E41, when he was downsizing. It has an interesting history. He was from Des Moines, Iowa, and he was home in 1999, and it turns out they were having very small indoor ham fest and near his house. So we went there, and he immediately spotted this very interesting black receiver or test piece of test gear in a back corner. And he zoomed back there and started talking to the people. It came with a doghouse power supply model 5886, and apparently it had an antique Jensen auditorium speaker, which I did not see, came with it. Didn't have quite a full set of coils. A couple of coils were missing. Richard pressed the seller, and they were fairly elusive, and at some point finally said there was no more coils. The seller also mentioned he had been employed at the property of a gentleman named Butler, a wealthy deceased Des Moines resident that lived in the Grays Lake area of Des Moines. And he had the first house construction of concrete. And so Richard did some research, and he says, I believe I'm the second owner of this radio. It came from the home of a wealthy Midwestern industrialist. His hobby was listening on the airline frequencies during the 1930s. He was a pilot. His son was an airline company manager at a local airport. And the radio station's chart includes the designations of several airlines that served the Midwest at that time. So here's the Earl Butler Mansion. When it was completed in 1937, it was called the world's most modern house. And it was on a hilltop overlooking Des Moines. It was made out of all concrete and steel. Originally, it had 28 rooms, and it was expanded later. Had very large floor-to-ceiling double-paned windows, and a number of the very modern features that we proudly have today. And it says, among many other things, Butler also was a pilot, and his son Edward was manager of United Airlines at the Des Moines airport. Earl Butler, the father, kept a searchlight near the third floor sunroom that he used to help planes find their way to the airport during inclement weather. And it says this room also features the tallest windows in the mansion, as well as one of many patios. So that's up top. So here's the chart for this particular receiver. And you can see, if you look in the middle, it says Boeing. NAT was another airline, American East, American TWA, American West, NWA, I believe, so, which would be early Northwest Airlines. So I wasn't able to find a picture of the control tower at the Des Moines airport circa 1934, but I did find a great article talking about the one in St. Louis, which is not too far away. And in this particular picture, you can see three AGS receivers over on the left, and GE actually had the contract for all the Airways stations, the radios, and so they supplied the transmitters, which would be over on the right. And it's so dark I can't quite tell what transmitters are over there, but you can see it's not really a searchlight in the center, it's a signaling light. And my guess is this is what Mr. Butler had upstairs that he would shine at airplanes as they flew over. So what we're seeing is a revolution in communications receivers, and why did this happen? Well, transmitter development was actually leading receiver development for a time. Hams were going to tube transmitters and crystals for frequency stability. James Land wrote a series of articles in QST, which established the guidelines for communications receivers for the next several decades. And the article was called "What's Wrong with Our CW Receivers?", showing that regenerative receivers were broad and unstable, and they had not kept pace with the advancements of transmitters. So here's a page from that article. Here's kind of a summary Said some of the features that he says we need in these receivers: electrical and mechanical stability, single signal CW selectivity, improved phone selectivity, reduced overloading, cross modulation effects, high sensitivity, better signal background ratio, less tube hiss. And he says he'll talk more about this in another article. And here's his prototype that he used. That's at least it was at the AWRL headquarter museum. The next article was called "Shortwave Receiver to Match Present Conditions," and it covered the basic receiver principles and manufacturing techniques and circuits. He said he used a crystal filter for single signal CW reception, showed how to stabilize the high frequency oscillator, and principles of quiet and electrically stable RF amplifiers were also covered. And here is that prototype receiver. So by December 1932, the first commercial receivers with crystal filters started appearing. And within a year, they were pretty much standard in all the better quality receivers. So here's a couple of ads for Christmas 1932 where they're leading with the term single signal. So and these. So I want to talk about a few other National Airways receivers that are related to the AGS. Here's a Fort Wayne Airport radio rack. At the bottom is your AGS. The next radio up is it's a TRF, not a superhet. It was to cover 200 to 400 kilohertz or so, frequencies that the AGS did not cover. There's dual coil sets. There's a nice open face speaker at the top and a dual power supply to power both the receivers. Here's a close-up view of the low frequency SW58C, courtesy of John K1VVC. Beautiful example. Only has two coils in the front. Here's the inside, beautiful construction. Not really a black color, more of a brown black color, which is correct for the earliest national radios. Nice dust cover. Now this ad, it has AGS at the top, has FB7 for the hams over on the right, SW3 also for hams, shortwave listeners over on the left, and down at the bottom it has something that says AGU and AGL. And it says these are also communications type shortwave superhets made for the Airways stations. And it says the AGU and AGL, they have different coil setups, and I want to talk about that a little bit. Here's a close-up view of an AGU, and it's similar to the AGS electrically, but instead of having three individual round coils, it has a rectangular module that with two finger pulls that look like coils, but it's actually three coils in a module. And there's two modules for the receiver, only two. This is the follow-up superheterodyne receiver for the AGS. This was supposed to be a improved model. Here's a nice article from the Old Timers Bulletin, February 1996, written by Bill Fizette about the RH airport receivers. So it gets a little confusing here, but some of the improvements was the coil module, and we're going to talk about that. The type BX dial, which is the cheaper, illuminated dial with the pointer, and they changed a few things in the they relocated the antenna inputs, and also they changed some things around with the audio output and that kind of thing. So I have a national RHP, and it's much rarer, by the way, than AGSs are. There was also an RHQ that looked just like it. Now, The funny thing is, National refers to these as AGU and never really mentions RHP and RHQ, but they're the same sets. Um, I've never seen an AGU data tag. They've always been RHP or RHQ, and I only know of maybe a handful of these receivers. But you can see the module in the top center here. This one covers from 4,000 to 6,500 kc, and in the center you see the Type BX dial with the pointer, and the nice data tag at the bottom, and it's in the top right-hand corner on the radio. So still says Department of Commerce, Aeronautics Branch, Airways Division, Lighthouse Service. So again, these were not used in lighthouses. These were used on the national airways while the beacons, the light beacons were being set up across the country. So there's only two coils. One goes from 2,500 to 4,250, and one goes from 4,000 to 6,500. And that's because the primary two frequencies used by aircraft going across the country at that time was 3105 and 6210 kilohertz. And so the RHP and RHQ and AGU coil sets are all the same. The serial numbers of the coils are on the side. In the top, the module is serial number 7, whereas the bottom it's serial number 24. Now these are fairly massive coils, and you can see them at top here. And I have an HRO coil down as for comparison. And of course, the coil module at top evolved into the HRO coil set as we know it today. And the one thing about the module on top, it was very, very well made, very well shielded, very heavy. So I've added the AGU or RHP or RHQ to this list. It's most similar to later AGS's, the tube lineups, but it does not have a crystal filter, has a different dial, and the IF cans are the shorter half-height cans, the same as the RHM. So it's sort of a mix of everything. And of course, they have the BX dial. Now here's another Airways radio station, circa 1929. It's got a slightly different receiver. This is the other receiver that was in that ad, the National AGL, which is also known as the RIO. It's not a superhet. It's for the low frequencies from 175 to 650 kc. It has two ranges, and it has band switching, so no coils at all. Here's a picture of a type RIO with a beautiful data tag, and if you look below the main tuning dial, which is also a BX dial, you see the AB. So that's your band change switch instead of having plug-in coils. So that was another change with this receiver. Also shown in this particular picture is it's a dual power supply, not made by National. It's made by another company in New York, and there's the data tag of it. So that was kind of interesting. So don't forget the National tabletop racks, because these are very hard to find. The shorter one is called an LRR, or lightweight radio rack. It's 24.5 inches tall. The slightly taller one is MRR, or military radio rack, 29 inches tall. And again, both of these are very uncommon. These disassemble, very well. Now, I have 5 AGSs here, and 3 different racks. One of the racks is 29.5 inches tall. Another one is 35 inches tall. Now, the tallest National tabletop rack is for a Navy RAS, which came later, and it was made for the Navy, and it has a 40-inch rack. So I just mentioned it because it's a very tall unit. when you're looking at these power supplies, these rack power supplies, the duals are harder to find, much harder to find than the singles. The singles they used up through World War II, but the duals were used early on. So here's a earliest example of a AGS speaker. I think it's made by Rolla. Here's another view. This is a later AGS speaker made by Jensen. They made single rack speakers. They also made dual rack speakers. Here's a pair of Jensen speakers these are permanent magnet speakers. Uh, and here's the national decal. And if you're lucky, you'll find these decals on the back of some of the racks or the speakers. Now, there was a competitor in the Airways receiver space, and that was DeForest. And he made an RHO, and there's only two known. And this is one of them. You can see it's got a module with a hand pull, and it's missing its main dial, so I don't know what the main dial looks like. But here's the data tag. High frequency receiver, type RHO, Department of Commerce, Aeronautics Branch, Airways Division Lighthouse Service, made by DeForest. And here's another tag. So it's also referred to as an RRH-10. I have not been able to find any information about that. I did see reference to a RRH-11 being used by the Navy, but that was all that I have found. And it also mentions Wolcott here. And someone told me something about the Forest radio when it was associated with Wolcott. But I'm not an expert about this. If anybody has any information about this, I would very much appreciate it. So here's my AGSX on CW. Got a great sound, and it's very stable too. Here's another weaker signal. And during when I'm listening to these signals, I'm playing with the various controls to see how the crystal filter functions and the BFO knob and that type of thing. And here's one more. And here's the AGSX on AM. So able to find a nice shortwave station. And the AVC does work on this radio. And this receiver is stable enough to work on single sideband.
last year before they took a break, and I'm sure they're devastated. High authority is closed. They said it would be closed westbound for at least a year. It worked one bridge away, and they've had a place down there where it works the road away.
So some of the issues with AGSs, there's no on-off switch on the AGS itself or on an early doghouse power supply. Also no fuse. Now, the AGS does not have a receiver standby switch for coil change. It does not have a standby switch for transmit receive operation. So it was really made just to stay on a frequency and be listening, 24 hours a day. So obviously the control tower was talking on one frequency and listening on another. The Type N dial is a very nice dial, but the HRO vernier, when it comes out, it's much better. And of course, the main complaint by customers about AGS is it just had too many coils. So, and you'll notice the color of this early doghouse is more of a brown, a two-tone brown, brownish black color, and that is correct for the earliest national products. Now, here's a beautiful AGS, serial number F19, friend of mine named Tony Peterson. He sent me this beautiful picture. If you happen to have a national AGS or a similar receiver, an RHP, RHQ, I would really like to hear from you. Here's some extra reading. Nice article in Electric Radio, July 1991, Henry Rogers, Radio Boulevard. A great article. Great article in November 1975, CQ magazine about the national AGS. Now, the next receiver, of course, was the HRO. And the first 100 HROs were the D series. And if you look up in the top left-hand corner, the serial number of the earliest HROs are stamped right in front of the antenna and ground post. In this case, that says D35. Well, that's the 35th HRO off the line. And D1, the first, is missing. It's no one, I think the lowest serial number known is something like 15. So keep your eyes out. If you see an HRO at a ham fest, make sure you look at the antenna and ground. If it says D or E or F, it's pretty early, and you might consider picking it up. So thanks to all these contributors. Couldn't have done this without them. And thank you very much for listening. Please subscribe to the AWA YouTube channel, and please consider joining the AWA.